Our fourth video from Chapter 5, Section 5.2, is about rational exponents. It's an extension of the first video where we talked about the first 7 rules of exponents. This one we'll talk about rule number 8. Hopefully we can keep this pretty short. So far we've only seen integers as exponents. You can see here already that we have a fraction as an exponent. The first 7 rules can still be applied when there are rational exponents or fractions, but this video we're just going to discuss how rule number 8 works and how you can manipulate it. So we have b to the x over y right here. There are 2 different ways you can write this. It doesn't matter whether you apply the x or the y first, but since the y is the denominator of the fraction, that goes inside the root. So we're taking the y root of b, and then we're raising that to the x power. So the denominator goes inside the root, and the numerator goes outside as an exponent. The other way you can write this is the reverse order. So we raise b to the x, and then we take the y root of that. So it can be written either way, but this is something you should definitely have in your notes and be able to apply. The directions here are to convert to radical form, so I want to make it look something like this. Usually I do the y first and the x second, but again it doesn't really matter. So x to the 2/3, we know we need a root involved. The x is going to go inside, that's our base. Remember, our denominator goes inside the root, so our 3 is going to come in here. We're going to take the cube root of x, and then we can square that. The numerator goes up top as a power. The other way you can write that, and I'll only do both ways for the first one, we could have taken the x and squared it, and then taken the cube root of that. So either one of those answers would work. For the second example, it's 2 times x to the 3/11, I'm sorry. A lot of people make mistakes with the coefficients, but you need to remember that this is really 2 times x to the 3/11. So only the x gets that 3/11. So what our answer here is going to be is 2 times, we can't do anything with the 2. We put the x inside the root. Remember, we take the denominator, the 11, so we take the 11th root of x cubed. And that's as simple as you can make that. That is in radical form. This last one down here, the parentheses, they tell you that the 6 is applied to the 3/4 as well, so it's important to know the difference between our second and third examples. How we would write that out, the 6 and the y are going to go inside the radical. Our 3 is on the bottom, so we take the cube root of 6y, and then we raise that to the 4th power. Converting to exponential form is going to be the exact opposite. We know our base here is a. We need to raise that to some kind of fraction. The 6 here is inside the root. That becomes our denominator. The 5 is the power. Now you can see in this one the 5 is applied first. Again, that doesn't matter. We should still have a to the 5/6. Second one's a little more complicated. One thing you'll notice is there's no number inside. We assume that's a square root, so that can be a 2. A is not raised to any power, so we can write that as a 1. So just this portion right here, just the square root of a, we can write as a to the 1/2. The 4th root of a, again there's no power of a up here, so we can write this as a to the 1/4. Let me get rid of that, that's not a 0. Now we go back to rule number 1 from video number 1. We know this, we can add these two since the bases are the same, we can add 1/2 and 1/4. I'm going to rewrite 1/2 as 2/4 so that we can add these. So the final exponential form for this expression is a to the 3/4. Last example down here is going to follow a similar thing. This time we do see the 2 in here, but we don't need that. So we have 3y. Since that's in parentheses, we need to leave it here too. The 5 and the 2 here and here have an effect on both the 3 and the y, which is why we need parentheses. And we can write our exponent as 5, that's our outside number becoming our numerator, and then 2 is the denominator. So that would be 3y all to the 5/2. The last thing we can do with these is actually evaluate them. We have no variables here, you can see that they're all numbers. If I rewrite this in radical form, this would be the cubed root of 8 to the 4th. The cube root of 8 we know is 2, so this becomes 2 to the 4th. And we end up with 16. So 8 to the 4/3 really equals 16. If you look down here, 81 to the 3/4, 4 is the denominator, so that goes inside the root. 81 is our base here, and then we want to cube that value. You'll get more comfortable with your powers of 2s, 3s, and 4s, some of the more common ones. The 4th root of 81 I know is 3. And then when we cube 3, we end up with 27 as our answer. You'll see here with the fraction, we need to apply this 3/2 to both the top and the bottom. Talked about that in the first video as well. So this is really, and you don't need this step, but it helps to see this is 4 to the 3/2 over 25 to the 3/2, which is really the square root of 4 cubed over the square root of 25 cubed, which we know is 2 cubed over 5 cubed. Our final answer here is 8 over 125. And that's it for this video, hopefully short and sweet. What you'll see in your packet for this section is problems exactly like we just did, and then problems just like from videos 1 and 2, except with fractional exponents. You can use the laws the same way you did then.